Data science isn't just another career path. It is shaping the future, and if you have chosen Python for data science, let me assure you, you are on the path to glory. Hello everyone, this is Wasim from Edureka, and I welcome you all to this session in which I'm going to talk about Python for data science. And by the end of this session, you will be able to extract, clean, manipulate the data, and make visualizations to derive understanding of the relationship between various aspects of the data. I'll be working on three different data sets to give you a wider perspective. A population data set for visualization, as you can see over here. So we'll be doing this. And then I'll be working on a FIFA data set to make predictions or to make a team based on observations. And finally, I'll be giving you a detailed stock prediction program using linear regression. But before that, let me tell you how we are going to approach this session. So I'll start with a brief introduction to data science, and then I'll tell you why you should go for Python for data science. Moving further, I'll give you a brief about a few libraries in Python for data science, and then I will discuss the data science lifecycle along with examples that I've shown you. And finally, I will discuss the jobs, salary, and company trends for data science along with how Edureka will help you in becoming a data scientist. I hope you are clear with the agenda. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. And do check out the Python certification training for data science. The link is given in the description box below. Now, without wasting any more time, let us discuss what is data science. Data science is primarily used to make decisions and predictions, making use of analytics, prescriptive analytics, predictive analytics, and machine learning. A data scientist's job is to analyze the problem and, based on observations and analysis, give insights and solutions to any problem faced by an organization, which is going to be driven by data. A data scientist is a problem solver. And there is a lot of misconception which has brought data science to a different perspective. People think that data science is all about making cool predictive models and visual representations. Although these are also a part of data science lifecycle, but data science is not entirely just that. We will discuss data science in its truest essence in this session. So let us go ahead and take a look at why Python should be your first choice for data science. Python has already made its mark in the industry with features like easy access, enhanced readability, extensive support, scalability, etc. And it is emerging technology which has achieved a lot over the last 2 decades. With a wide variety of professionals using Python, it is an easy choice for data science. A data scientist would never want to engage his time into figuring out the implementation of any task. So with Python, even the complex looking tasks become a piece of cake, which makes it even more desirable for any data scientist. And when it comes to library support in Python, Python has almost everything bind up in a library. It is like you think of an idea or a task, and Python would come as a savior each time with an even more appealing library support. A data scientist's job becomes quite easier when you already have a library to do your task. It is like telling Python to do something that normally would take you days to figure out. And with all these features and advantages, the development also becomes very fast. And if you are able to do a task in, let's say, 2 days with Python, and the same task would take you 4 days with other programming languages, it does not really take a genius to tell which programming language you should go for. So let's go ahead and take a look at a few libraries that we have in Python that makes a data scientist job easier. So let me just briefly tell you about all these libraries, and then you'll be able to understand how these libraries work when we work on the data science lifecycle. So first up, we have NumPy. So NumPy is a Python package which stands for numerical Python, and it is the core library for scientific computations. It contains a powerful n-dimensional array object which provide tools for integrating C, C++, etc. It is also useful in linear algebra, random number capability, etc. NumPy array can also be used as an efficient multidimensional container for generic data. After this comes matplotlib. So matplotlib.pyplot is a plotting library used for 2D graphics in Python programming language, and it can be used in Python scripts. You can use it in shell, web application servers, or other graphical user interface toolkits as well. After this, we have pandas library. So pandas is used for data manipulation, analysis, and cleaning. Python pandas is well suited for different kinds of data such as tubular data with columns and ordered and unordered time series data. We can use it for arbitrary matrix data with row column tables, and we can use it for unlabeled data as well. And any other form of observational or statistical data sets, we can use pandas for it. After that comes the Seaborn library. So the Python Seaborn library is used to ease the challenging task of data visualization, and it's based on matplotlib. So Seaborn allows the creation of statistical graphics through some functionalities that are an API that is based on datasets, allowing comparison between multiple variables. So you'll be able to understand this when we are working on the dataset, guys. So don't worry. And it supports multi-plot grids that in turn ease building complex visualizations, and univariate and bivariate visualizations available to compare between subsets of data. And then we have the availability of different color palettes to reveal various kinds of patterns, and it estimates and plots linear regression automatically. So that's a win-win situation for us, guys. I'll also show you the estimate, and we'll plot a linear regression in the population dataset as well. And last but not least, we have scikit-learn. Although there are so many libraries that you can use for Python in data science, but these are a few libraries that are actually very necessary when you're working on data science. So when it comes to scikit-learn, scikit-learn is a library used to perform machine learning in Python. So scikit-learn is an open source library which is licensed under BSD and is reusable in various contexts. It encourages academic and commercial use, and it provides a range of supervised and unsupervised learning algorithms in Python. And scikit-learn consists of popular algorithms and libraries as well. So now that we are done discussing these Python libraries, let us take a look at the roadmap to data science with the data science lifecycle. So the lifecycle starts with the business understanding. It basically tells us what kind of problem we are dealing with. In this process, we figure out what is the objective of our analysis and what are the insights on result that we are expecting to achieve. And then we start collecting the data. We'll analyze it for anomalies and clean the data as per our requirements. And we will also do the data wrangling, which includes manipulating the data to reach the insights and results. And then comes the visualization part, where we understand the relationship of various data points with the help of visual representations in a way that we will be able to derive to a conclusion just by looking at the representations. And last and final process is the model selection and deployment, where we put our data to train and test the model in order to derive conclusions. So now that we know how it is done, let us understand this with a few examples. So we have come to the Jupyter notebook. So first off, we have a Russian demography data set. So we will analyze the data and make a few conclusions based on the observations. And we will use the Jupyter notebook for these examples. You can check out a full detailed tutorial on how to work with Jupyter notebook along with Python Anaconda installation and the other features on Edureka. Although it is quite easy to work on Jupyter, I'll just walk you through the basics quickly. Like after installing the Python Anaconda, we can directly open Jupyter notebook from the start menu. Like you can type Jupyter over here and you'll be able to open the Jupyter notebook. I have this home page, guys. So from this, I can use this new tab over here. I'll open a new notebook, which is Python 3. I'll name it as, let's say, example 1. Before starting with example, we have to make sure we have installed all the dependencies so that we don't have to do that later. So for this program, I'll have to import pandas library. All these libraries that I've told you already. I have to import numpy. Then I'll import seaborn. And I'll import matplotlib.pyplot as plt. So no errors here, guys. I'm successfully able to install all the dependencies. The kernel is still running, so we'll know it for sure after a while. And after installing the dependencies, what we are going to do is we will read the dataset using the read CSV from the Python pandas library. Okay, I'll name my dataset as df. Using the alias that is pd, I'll read from the CSV file. And here I have to mention the file location. And name of our file is demography.csv. Now if I run this, I'm getting this error, which is Unicode error. To resolve this error, I just have to do one thing. Write R over here. And you can see there's no error. We are successfully able to read the dataset. So after this, we will take a first look at our dataset using df.head. So it will give me the first 5 rows from my dataset. So as you can see, we have this data. And there's one more thing. And we can also take a look at the data from the last 5 rows. So as you can see, we have this data and we have these columns like year, region, NPG, birth rate, death rate, migratory growth, and population. So this is our data set, guys. So we have the first look at our data. And by looking at these first 5 rows, we can figure out what our data has. We have 7 columns, namely year, region, NPG, birth rate, death rate, and we have migratory growth and population. So now we will move on to cleaning the data, which is basically checking for the null values and replacing them with other values just by dropping these columns. So I'll give it a heading, guys. Okay, I'll just make it a little bigger for better visualization. And I've given a heading like data cleaning. Let's first of all check the shape of our data set. So we have 2380 rows and 7 columns. After this, I'm going to check the columns as well. I already know what are the columns, but we can check it as well. So we have the index as year, NPG, and all those things until population. So 7 columns we have. And I can even check the df.info, which will give me the information of my data set. So I have all these values like year, it is a non-null integer object. And then we have region, which is a string. That's why it's showing the data type as object, float, and all these things. So after this, what we are going to do is we will describe our data set to get all these values from our data set so that we can understand what we are dealing with. So if I use the describe method, what you can see is I am getting the count of all these columns, that is year, NPG, and all these things. Then we have the mean value for each column, and then we have the standard deviation, the minimum, and 25%, 50%, 70%, and maximum as well. So this is what describe method does to your data set, guys. And after this, what we are going to do is we're going to check for the value counts. What I'm going to do is I'll write df dot region. So I'm going to use the region column from my data set. I'll use the value counts. So it's going to count the values and I can drop these values as well. So I'm gonna drop a column that would not be necessary for our assessment. And in this case, we will drop the region column and migratory growth as well, because we will take a look at the whole demography instead of any specifics. And after that, we'll clean the data from the null values by replacing those values with 0. So I'll just drop region and from the axis 1 in place is equal to true. So it's gonna drop my column, guys. If I check df now, I don't have region in this. Similarly, after this, I'm going to check for the null values. So we have all these null values in NPG, birth rate, death rate, migratory growth, and population. What I'm going to do is I'm going to fill these values with 0. So what I'll do is I'll do df.fill na 0 in place is equal to true. Now when I check the null values, we have 0 null values in our data set because I have replaced those values with 0. After this, I'm also going to drop the migratory growth because that's not necessary for the analysis that I'm going to show you guys. In place is equal to true. So this is what I was talking about, guys. These are the real processes that goes into data science, guys. First of all, you have to clean the data and manipulate the data, but most of the people are attracted to the fact that you will be working on cool data sets to make prediction models. I'm not denying the fact that it also includes a lot of processes to make prediction models, the data science lifecycle, but that part comes after you have mastered all these processes before going to that. So make sure you master all these processes beforehand before you move on to making prediction models. So now when I check my data set, I have no null values and I have dropped 2 columns. So these are the columns that I'm going to be using for making visualizations. We have population, death rate, birth rate, NPG, and year. I'll give one more heading, guys, visualization. So first of all, what I'm going to do is I'll be relating the variables with scatter plots. So first of all, I get the first 5 rows from my data set, guys, for better visualization. So I'll be able to figure out what I have to do and all. And the first plot, I will be using the Seaborn library, from which I'll use relation plot. Okay, I'll just tell you what all goes in here: x, y, and then we have to give the data as well. So for x, first of all, I'll use npg, and for y, I'll use, let's say, death rate. Okay, we have an error, guys. I'm not given the data, which is df. So we have our first visualization, guys, first plot. So it's showing the relationship between npg and death rate. And as you can see, these values are those values which we have replaced with 0. So don't worry, guys. So there's a relationship between death rate and npg, which is going downwards. So as the npg moves forward, the death rate also comes down. npg is nothing but national population growth, guys. So if you're wondering what npg is, and after that, I'll take one more. Okay, I'll just copy this whole thing because we'll be plotting a few relation plots. And now instead of death rate, I'll use the birth rate. So we'll see the relationship between NPG and birth rate as well. So as you can see, we have one more plot. This is very relatable, guys. As the NPG is going forward, the birth rate is also increasing. So we have a linear relationship between birth rate and NPG. So I'll also show you the linear relationship using a plot from Seaborn library later on in the session. And after this, I'm going to use one more plot in which I'm going to put the population as well, which is going to be the hue. Hue is nothing but it's going to show the relationship between death and NPG with respect to the population. So I'll write it as population, and I want to give it a constraint, guys. So I want the population to be less than, let's say, 50,000. We have a graph over here, guys, or let's write as 100,000. So there's nothing major change in this plot. As you can see, population is pretty similar, guys. And if I remove this constraint, let's see what the output will be. So we have the complete hue over here. So it's starting from 0, then going 50, 100, and 150. And as you can see, we have the relationship in this plot. After this, we can use the same plot to check for the birth rate as well. So I'm sure, guys, you must be able to identify a few relationship between these variables that I'm showing you. Now we can also make the line plots to show the continuity. For that, we don't have to actually do anything. We just have to replace hue with kind. Okay, I'll just show you, guys. So instead of hue, I'll write the kind as line. And when I plot this, let's see what the output is. So we have a plot somewhat like this. And we can do the same thing with the death rate as well. I'm sorry, the birth rate. And similarly, we can check for the population as well, the relationship between population and death rate. So it's a little haphazard, but I'm just showing you how you can check for the relationship between all these variables. Clearly, we have a relationship between birth rate and death rate with NPG. It is not clear with population and death rate. So we'll check for population and birth rate if there is any clear relationship that we can figure out. Same thing with birth rate as well. So it is not actually very clear looking at the plot over here. What is the relationship between population and birth rate? So to make this clear, what we can do is we can add CI and we can add estimators. So what I'll do is I'll just write CI over here. Let's say none. Okay, we're not getting any changes in that as well. So let me just add SD constraint over here. Nope, we cannot figure out the relationship between population and birth rate. Like we have birth rate going from 0 to 30 and we have these populations over here, but it is not actually very clear, and we should move on to the estimators to see how it works. So instead of CI, I'll just write estimator is equal to, say, none. We'll move on to the next plot that we have, which is subsets of data with semantic mapping. So what we'll do is we'll use the relation plot again, but for subsets of data with semantic mapping. For X, we'll use, let's say, population. why, let's say we are using birth rate again, and hue, let's say I'm giving NPG. So I want to check the relationship between population birth rate with respect to the NPG. And I'm going to use the kind as line, and data is equal to df. So let's see what the output is. Okay, so we have a very haphazard kind of plot over here. So we have the NPG in the hue, which is going from -30 to 30 and 15 0. We have population is given over here, the birth rate is given over here. So most of the birth rate is in between 5 and 20, but we are not really able to figure out what is the relationship over here. So we'll move on to the next plot. So let's take a look at a few more observations. So what we'll do is we'll use the cat plot now. In this, let's say I'm giving the X as year. So for each year, I want to check the population. This is an interesting plot, guys. I'm using the data as df and height as, let's say, 5, and aspect is equal to, let's say, 2. I'm going to change these values. Let's say aspect is equal to 1, or I change the aspect as 3. So we have a clear relationship. So in 1990, the population is going over here. Then we have similarly for each year the population. We can use jitter, and we can add variations in this plot to understand the relationship between all these variables that I'm using inside these plots. So the point of using these plots or making these visualizations is to understand the data set or understand the relationship between all these variables. With visual representation, it is quite easier. I mean, for the year 2017, the population is going as high as 1.2. So this is a clear relationship between the population growth. As you can see, the growth is going from here and it is moving upwards. This is a relationship that I'm able to see from these plots, and this is the main objective of using the visualization in data science. Next up, what we'll do is we'll use the cat plot again, and we will give the jitter as well. So inside this only, I'll write jitter is equal to false. So I'm getting the clearer relationship. So when I did not have jitter, what happened? I was getting the values somewhat haphazard. And when I added the jitter, the output changed to this. So this is clearly a win-win situation to understand the relationship between the variables through visualization. And similarly, you're going to use the cat plot again. And okay, I'll remove the jitter now. I'll use the kind as swarm. So let's see what the output is now. So I'm getting the output as swarm. So the population is mainly in between the 0 and 0.2, starting from there. And it's going upwards, and we can see the relationship again, but we are getting the plot in the form of a swarm. And instead of swarm, we can use the box, which is going to give us the box plot. And I'm using Seaborn because this is very easy. I mean, the implementation with all these graphs is very easy with Seaborn. I'm using Matplotlib. It's going to be not a very long task compared to any other programming language. Python is the best there is, but I prefer Seaborn for this because it has more visual representations than Matplotlib. So we have a box plot as well, and we can use the violin as the kind. So clearly it is growing from all these years. That is the relationship I can understand in all these years. I can use the bar as well. So with the bar graph, you can actually see we are getting the populations correctly. So to understand this relationship, you have to hit the trial and error method, or you have to understand what kind of plot or what kind of representation would be suitable for your data set. So this is how you can only figure out what is going to work for you and what is not. So clearly we have a relationship here, which is year in population, and we are able to figure out what is happening here with the help of a cat plot in which we are using the kind as bar. So after this, I'm gonna make a count plot, guys. For that, we're gonna use cat plot only. So I'm gonna check the count of NPG over all these years. So I'll write the kind as count. And here comes the color palette also. So we'll add a color palette which is equal to, let's say, ch26. Data is equal to, let's say, df, and we'll write the height as 5 and aspect as 3. So this is going to give me the count plot of the observations. So it is clearly not visible enough to understand. So what I'll do is I'll write the data for the first 100 rows so that it is clearer to understand the relationship or to understand the count plot. Or we can change the color palette. So instead of 26, let's say I'm using 23. See what the color changes to. Okay. So the NPG is actually growing. The highest NPG is around 6, and then we have a smaller, the uniform NPG which has remained over all these years is 1. So we have understood the relationship here as well. And after this, let's take a look at little more visual distribution, like how the data is distributed around all this data set. So what we'll do is we'll use the disk plot from Seaborn library, and I'll use the birth rate. Bens is equal to, let's say, 10. KDE is equal to false. These are all the values that you get inside all these plots or functions, that like this plot, you have all these values. Don't worry guys, if you looking for a detailed tutorial on how to plot all these graphs using Seaborn or Matplotlib, we already have those tutorials on Edureka guys, so you can just go there and master all these plots yourself, which is going to be good for you guys because you'll be able to understand how these plots work. And I'm just telling you how you can use Python for data science. This is all what goes inside the process of data science. And if you're looking to master all these plots already, you can check out the tutorials on Edureka. We have Matplotlib, NumPy, Pandas for all these libraries that I've told you in the dependencies. We already have full tutorials for that. So you can just go there and check out all these tutorials. I forgot to mention the data guys. So we cannot use data inside this. So what I'll do is I'll just write df.birthrate. Yes. So I'm getting the distribution around this birth rate using this plot. So similarly, I can do it for population as well. So I'll just write population over here. Okay, so I'm getting the population as well. After doing the birth rate and population, we can do one more thing. We can use the plot for NPG to understand the distribution, guys. And bins, if I write it as, let's say, 5, and let's check for death rate. So I'm getting the 5 bars to show the distribution. So death rate around 10 to 15 is the highest. That is my point here to show the distribution. Or we can write it as, let's say, 20 as well to understand better. Like 10 to 15 or around 15, the death rate is the highest. Like more than 400 samples are there which has the death rate more than 15. So I hope this is clear to you guys. For this, we can use a few plots or a joint plot actually. So for that, I'll write sns dot joint plot. X is equal to npg. And to understand how we have to approach this visual representation part, you can go to Seaborn official documentation. You'll find a structured way in order to get all these plots according to your data. So it's divided into 4 sections where you can just find out which data your dataset belongs to and then what are the representations that you can go for. So there's no need to worry about how this is going to work or how it is actually working. It is all about showing you the representation between all these variables. So you just have to look at the plot, figure out what is the relationship, because plotting all these visual representations is a piece of cake, guys. I mean, you just have to give a few variables in the X and Y, and then it's pretty much Python will do the job for you. So you don't have to worry about learning all these things. But in order to master all these concepts, you have to practice a little, work on a few data sets, and understand the relationship between all these variables, so that you will be able to reach to conclusions that you want from, or the problem that you're looking to solve. You should be able to reach to conclusions that will define the solution for your problem. And we have the joint plot for birth rate and NPG, in which it is showing me the relationship between NPG and birth rate through scatter plot. And on the up, we have the distribution as well. So this is what joint plot does to you guys. I could have just used it in the beginning also, but I had to show you the relationship or how you should approach looking at the relationship between the variables. So don't worry guys. Okay, I'll just copy this code because I'll be using this again. Now what I'll do is I'll make a few changes, like kind should be hex, To make it more clearer or visually attractive, color, let's say red. Let's see what the output is now. So we're getting the same joint plot, but we are getting the distribution in a hexagon format. The scatters plots are in hexagonal shape. Then we have the color as red, or I can use green. So this is what you can do with this joint plot to understand the relationship in a better way. And for kind, we have KDE as well. Let's see what KDE actually is. So this is what KDEs actually look like. So we have the relationship between NPG and birth rate. These are the visual representations that you can check or you can look for when you're working on any data set. And this is comparatively a small data set with only a few columns, but the number of rows are pretty good. But still, it is a small data set, so the relationship between these variables is pretty easy to find. But when we are working on larger data sets, which I'll be showing you when we are working on FIFA, you will be able to understand how to work with large data sets as well. And last but not least, I want to show you a linear relationship between the variables, how you can find it through the visual representations. So for that, I'm going to use Regplot, and inside this, I'll give the values NPG and Y should be birth rate, because we already seen a relationship between NPG and birth rate through all these visual representations that we have executed. Okay, we have an error over here. Okay, instead of date, it should be data. All right, so this is what Regplot will show you, the linear relationship between two variables, that is NPG and birth rate. It is also giving us a best fit line as well. And one more thing I want to show you is LM plot. I'll copy this, paste it over here instead of Regplot, LM plot, NPG and birth rate. So let's see what the output is now. And for this, we can add the X estimator. Add the X estimator is equal to NP dot mean, which is going to take the mean of all values and estimate parameters and show us the relationship using the LM plot. So after all these observations, we can come to a few conclusions. Like there is a linear relationship between NPG and birth rate. And then we have plotted all these distribution graphs where we can see that the death rate among 14 and 15, the value of 14 and 15 is more than 400 samples. Then we can make a few conclusions using the NPG, like the count. What is the count of the NPG, the highest number of count and the lowest number of count as well. And then we have seen the population among all these years, starting from 1990 and 2017. Then we have plotted a few graphs. Okay, so we were not able to make any conclusions from this subplots that we have used, but we were able to figure out what was happening in all of these. And there's one more thing that you can do in starting as well, getting the pay plot inside this DF. Let's see what this does, guys. It is very easy and you will be able to understand this very quickly, guys, because it will show you the relationship between all these columns that you have with respect to each other. Okay, so we have all these plots. So we have here NPG, birth rate, death rate and population, and similarly we have population, death rate, birth rate and NPG. So if you look at NPG, so population and NPG is not clear, that it is scattered all over the way. And then if we compare it to death rate, it is coming down. So we have a relationship kind of thing. Then with birth rate, it is clearly showing a linear relationship. And then we are checking the NPG with NPG. So it's showing the count. And then for a year, it is also scattered. So using the pair plot as well, you can also check for the linear relationship in any data set. So for the next example, I'm going to make one more file. I'm going to name it as football team. And first of all, I have to install all the dependencies to start with. So I'll import pandas as PD and all the other dependencies as well. So in this, I'm going to use matplotlib, guys. So you'll be able to understand how similar matplotlib and Seaborn actually are. So first of all, I have to read the data. So for this, I'll mention the file location. So we have the FIFA 20 complete dataset. Copy the file location. To avoid any errors, I'll write R over here. And I have successfully imported the data into my program. So we'll take a first look at our data. This is our data, guys. So we have a FIFA ID, player URL, short name, long name, age, date of birth, height, centimeter, weight. So we have 5 rows and 104 columns, which is a very large number, guys. So let's take a look at a few more details inside this data that we have loaded just now. Okay, so we have almost 18,277 entries inside this data set, which is pretty good for a data set because it's a long data set. So the evaluation that you will do is going to be a lot more accurate because we have a lot of data. The thing with data science is the more the data, the accuracy will be more. I mean, there is a chance of overfitting and underfitting that comes later, guys. So don't worry. First of all, let me check the columns, which I have told you there are 104 columns. So it's not going to show all the columns, but I'm only going to need a few columns from the dataset for my evaluation. So I'll check the shape as well. We have 18,278 rows and 104 columns, which is pretty good for this dataset. So what I'll do is I'll get one more data frame, name it as FIFA. And again, guys, if you have any trouble relating to the content of this session in respect to pandas or any other library, like what is the data frame and all, you can check out other tutorials on Edureka, which are going to show you the full detailed tutorial on how you can use pandas and what exactly is data frame and all the other details that I've already told you in this session to make it more relatable to you guys. So before doing this, you should check out other tutorials as well. So I'm going to use data and I'm only going to use a few columns. So all those columns are that I'm going to use short name. So I'm going to use the short name and then I'm going to use age. I'm going to use height, which is given in centimeter. And then we will use the weight as well to get a few representational, and the weight is in kg. I don't want any trouble while pouring all these. And then we want the club as well. We want the nationality of the player as well. Don't add that where he's coming from. Now we will add overall rating and potential rating as well. So we have in this dataset two columns that have the potential, that is the player potential rating, and the overall rating. Overall is actually calculated using all these skills. Okay, I'll just show you the dataset once. So this is my dataset, guys. Inside this we have so many columns that we can just draw. Like we have team position on all this, shooting and dribbling, defending. All these columns are taken into picture and the overall is calculated according to this. I'll just close this, go back to Jupyter. Now after team, I want to, okay, this is team position, which is going to be very crucial for us because we are going to decide the best team for formations, which is going to be 4-4-2, 3-5-2 and 4-3-3. For that we have to know what player is actually playing for which position, and then we'll add the team jersey number as well. Okay, so when I get the values from FIFA now, so we have one more data frame which has short name, age, height in centimeters, then we have weight, the club, we have nationality, overall rating, the potential rating as well, and then we have team position and team jersey. So team position is not showing over here. Okay, so it should be done now. Okay, so the data frame is complete, guys. Now what I'll do is I will clean the data. For that, I'll check for the null values. So we have null values in team position and team jersey number. So what I'll do is I'll just drop these columns because anyway, if you don't have team position inside the data set and there's no team jersey, there's not going to be any use for you in the best team because we'll not be able to determine which team position you are playing at. So we can just drop these columns. So what I'll do is FIFA dot drop NA, and now if I check the null values, like how many null values are actually there, it should be 0. So our data set or the data frame that we are going to use for making the team is actually clean now. And we will move on to the evaluation right now. So first of all, to evaluate, I'm going to check for the top players that we have. For that, we can just write FIFA.short name. And I want to check for the players only that have the overall, which is greater than, let's say, 88. And the potential should be greater than, let's say, 89. And when I write top, so we have all these 15 players or 15 names that have the overall which is more than 88 and a potential more than 89. So this is it, guys. We have the top players, but we don't know the team position which they are playing for. So we have to make a few more changes inside the team to figure out what we are working at. So let's take a look at a few visualizations to understand the relationship between all these constraints that we have in the dataset. So for that, I'm going to use the cat plot, and I'm going to use X, let's say age, and Y, let's say we'll make the count plot. Data is equal to FIFA, height is equal to 5, and aspect is equal to 3. If we have an error, SNS is not defined because we have not installed. So we have a count plot, guys. So the most number of players in the datasets are from the age group 22 and 23, and it's going downwards from there. So we have players ranging from age 42 as well. So there are a lot of players inside this count we have got from the cat plot. After this, let's get one more. So we'll check the count plot. Yeah, I'll just copy this. Get the count of players with the potential. I want to see what the potential is ranging like. Okay, so we have a potential clearly between 69 to 75, the most number of players that is ranging until 1200. So my target is around 80 to, let's say, 95. I want people to be under that. There are a lot of players, like more than 200 players there. So it's not going to be a problem for us. But the only constraint that we have is the team position. Let's say if we have a center back, it's not necessary that he'll be landing around in this area only. He might be having the overall potential, let's say 73 or maybe 79. Or the best player in the data set with the center back position might be landing in this 79 potential, but we'll not be able to figure out that if we target this one. So let's check for overall as well. All right. And let's say what all clubs that these guys are playing for. So I'll write X as club, and I'll write Y as overall. Kind I want box, and that's it, guys. And I'm going to be using the data set only for the first 30 rows because all the players are, and the overall is actually ranging from descending order. Like the highest overall that we have for a player is ranked at the top of the data set, and then so on. So I've just taken 30 rows from the data set to get the fact that what all clubs these guys are actually playing for. So we have for Barcelona, the overall is ranging from 89 to 90s. So that is one club we have to consider. Then we have Juventus, which is around 85 to 91. Then we have Paris Saint-Germain, which is around 90, which is very good. Then we have Atletico Madrid. Only I think only one player is there. That's why it's showing only one dot. And then we have Real Madrid, Manchester City, Liverpool, Napoli. Then we have Tottenham, Manchester United, Chelsea, and Bayern Munich. So this is one relationship we have got from this. Now let's check a few more relationship points. So I'm going to check the team position now, which is the only constraint that we have, which is going to be used to making our team. I'll remove this. Okay, that's nice. So we have right wingers, left wing. Substitutes are the most over here. So we have all these positions that players are actually playing for. So according to this, I can make our best team formations. So first of all, I'm gonna make the best team for the formation 4-4-2. So I'm just gonna make the best team for the formation 4-4-2. So for this, the team positions will be left back, and then we're gonna have two center backs, and then we will have one right back, a left mid, right mid, center mid, in fact two center mids, and we will have center forwards. So this is going to be my team, guys. Now I have to figure out what all players are ranking the most on overall or whatever in these respective team positions. I'm just gonna write the code for getting the plot. Figure size is equal to, let's say, 10 and 6. Now SD is equal to FIFA. I'm just defining this whole program to get the logic. So I'm using this SD to figure out. I'm using the FIFA dataset. Inside it's going to be at the team position. I'm taking the team position as left back. I'm going to sort the values with respect to the overall, and I've assigned it to be false. So it's going to show me from all the values top down, and I'm taking only the 10 values. I can just take the 5 values as well. I have to put it into an array of list. It's going to be SD, and it's going to be short name. I'll copy this again. Y2 is equal to, right, copy. Y2 is equal to nb.array list as the, instead of short name, overall. Now sns dot bar plot x2 y2 palette. I'm taking at, let's say, HLS, and let's give a few labels as well. LB score. So let's see what this code does. Okay, we have an error, guys, which is false. There's something we have done wrong. So we had a few syntax error in this line of code, guys. So I'll just run this. So we are getting the 10 values, or not just 10, just get only 8 players first of all to get a clearer picture. So for the LB position or the LB team position, we have all these 8 players with the highest overall. So we have Jordi Alba with the highest overall, which we can use. Okay, I'll just write as HLS again. So we have Jordi Alba, and then we have Alaba, Marcelo, Alexandro, Robertson, Alex Telles, Grimaldo, and Digne. So these players have the highest potential for left back. So this is how we can figure out what all we want in our team. Okay, this is how you can get the best player for the positions. And I have already made this FIFA dataset using the FIFA dataset. I've already done this project, so it will be easier for you guys and less time consuming. So after all these visualizations, we have the best team formations. For 4-4-2, for left back, we have this Jordi Alba, David Alaba, and in this I have only used the 5 players, the top 5 players. And for the right back position, we have Joshua Kimmich and Carvajal and all these players. And for each position, I've done this to get the best team out there. And for team one, we have, like, for left back, we have Jordi Alba, and then Divri, Acerbi, Kimmich, Aubameyang, Eriksen, Campbell, Luis Alberto, Robert Firmino, and Karim Benzema. And for 4-4-3, similarly, I have LCB, CB, and RCB, and then we have LCM, RCM, CDM, left wing, right wing, and striker. So in right wing and left wing striker, we have Lionel Messi and Cristiano Ronaldo in the addition of the team for the highest overall that we have. And after doing all these representations or visual representations, doing the analysis, I have come across with 3 teams inside this. So I'll just show you those 3 teams. So the team 1 has Christian Eriksen with team position. Then we have pace, which we have added from over here. Like, you can just add a few columns in FIFA skills using the FIFA dataset. From these, like team 1, then we have team 2, and after this, I have done the team 3 as well. Then you can also check for a few relationship between like what is the team position and what is the shooting using the bar. If you have the right mid in your team, the shooting is above 80, and then for the center back it is coming around 40, which is not needed because a center back does not need to shoot a lot. But in the case of a center forward it is quite high, which should be because he has to do a lot of shooting. And then for the left mid as well, there's a high shooting value, which is kind of great because he's playing in the left mid, the midfield, and the shooting is good. So he'll be able to take the shoot from longer distances as well. So now that we're done with the data set with the FIFA as well, so we have these three teams that we have made using the evaluation we have done on the data sets. We'll move on to the next one that we have, which is I'll just make another notebook, name it as, let's say, stock data. It already exists. So I'll just write prediction stock. So what I'll do is I'll import the dependencies first of all. So in this dataset, I'm going to show you how to predict the stock value on a single stock data, which is I've taken from Google data. From now here comes the scikit-learn library, guys, in which I'm going to use the linear model for importing linear regression. So I'm going to show you linear regression, guys. So with the help of linear regression, we'll be able to work with this data set and to predict a few values for our stock. And after this, I'm going to import date time as well. This is a very important module, guys, date time. If you don't know about this, I suggest you to learn date time as soon as you can because this actually troubles you a lot when you're working with a data set which involves a few values with the date time. I'm going to just read the data set. This is my data, guys. So I'm just going to use the train set over here. I'm just showing you how you can do it. So I'm just using the train set so that it will be easier for you to understand how you can do the prediction, guys. Okay, we have an error, guys. There is no need to add that, and we have successfully imported the data. We'll take a look at our data. So we have date, open, high, low, close, adjacent close, and volume. But the only column that will be useful for us is the date and open, because open is the amount or the price of the stock at that particular time. So these two columns are going to be useful for us to make the prediction model. So what I'm going to do is, okay, let's just take a look at our data. So we have all these values, and you can see there is no value for date because it is actually an object, or we can call it a string as well. So for that we have to do a few computations in order to get it at some level that won't cause any problem for us. Check the shape. So we have 1259 rows and 7 columns. Out of those, only 2 will be useful for us. So let's just check, is there any null values? Okay, no null values because our data is clean. So we don't have to do the data cleaning part inside this one. I'm going to do a few changes to my columns in order to make them efficient enough to make the prediction model without getting any errors. So I'll write df dot date. First of all, I'm changing the type to string. So my date type has been changed to string, and after that I'm going to change or replace all those values that we have inside the date column, like hyphen, with nothing, and change it to float value. Okay, we have an error, guys. There has to be a capital D over here, and we have done that, guys. So I have changed the type of my date variable or the column over here. So first of all, what I did was remove all these hyphen from over here, convert it into a string, and then convert the whole data type into float. So now when I'll be working or when I'll be making the model, it won't show me any errors. So I'll take one variable df. So this is going to be my dates variable, and then prices I'll take open, and I have to reshape the values as well because it will show me the errors if I don't do that. So all the values I have to reshape, -1 and 1. You'll be able to understand this better if you have worked on So you'll be able to understand this better why we are reshaping the values over here. If you have worked on NumPy array, guys, this is a simple implementation to show you actually how it's done. Now I'm gonna call my model named as, so I have called my model linear regression, and I'm going to use the fit method to fit my variables x and y. Okay, so I'm getting this error again, guys. Could not convert string to float. That is 2013 and 01. So there has been some error, guys. Okay, I'm gonna run it again. I'm getting the same error. Could not convert string to float. Okay, so what I did was I changed the data frame number over here. I named it as df1 because it was taking the value from this, because it is in string type. After that, I had to name it to different value to make it clearer to the model that it is coming from two different values. And after this, I'm going to take a variable predict, and I'm going to predict a few values. So I'm going to predict two-dimensional, let's say at the value 10. Now when I print predict, for the 10th value of x, that is my date, the price is going to be 415. So if I name it as, let's say, 500, it's going to be 543. So for the single stock data, I'm able to predict the price. For X, I'm just providing the date and it is giving me the prediction of the price. I'll show you the plot as well. So I'll just write plt dot scatter inside this X and Y. Color, let's say I'm taking it as blue, and plt dot plot X, and inside this I'm gonna take predict X. Yes, and I get the values right. So I just make it as green. So we have a best fit line for all these years, and this is how you can make a simple prediction program for checking the stock price for a single stock. This is a single stock for the data that we have for Google data, and it is ranging from 2013 to 2017 for each date. And for each value of X that I have, it will predict the price, and it is eventually showing me the plot as well. So now that we are done with the examples as well, let us take a look at a data science trends across the globe. And I'm sure you have understood what I've told you in the session, guys. So when it comes to data science job trends, it is the hottest job profile in the 21st century as of now. With an abundance in data creation, it is just the tip of the iceberg. Billions and billions of bytes of data is created every day. And to make use of this data is the need of the hour. With more than 80% of the recent data created in the last 2 years, the demand in the market has taken a big leap as well. It is estimated that more than 11 million jobs will be created for data science by 2026. And even now in 2020, the job market looks quite promising with more than 300,000 to 2.7 million jobs opening. And one more advantage of being a data scientist is that you will find a data science related job which will be open for 5 more days compared to any other open job in the market. And in the year 2020 alone, the job openings are expected to grow a 600,000 more in numbers. So let us also take a look at the salary trends across the globe. So for a junior data scientist, the average salary ranges from $86,000 a year in the United States to at least a 7 LPA in India. And in the case of a data scientist, the average salary ranges from $113,000 a year in United States to at least 11 LPA in India. And for a senior level data scientist, the numbers go as high as $134,000 a year in United States and a whopping 20 LPA in India. And when it comes to the companies using data science or data scientist roles, there is no need to go into the specifics as almost 9 out of the 10 companies are driven by data science, since data is the basic necessity in any organization. Now let us take a look at how Edureka will help you in becoming a data scientist. So Edureka offers you a Python certification training for data science that will include all the data science concepts with much more. And we have the curriculum which is top notch and structured in a way that it aligns perfectly with the industry standards across the globe. The additional features include hands-on projects, 24/7 support, expert instructors, live classes, and lifetime access as well. And at the end of the certification, you will be able to programmatically download and analyze the data, learn techniques to deal with different types of data, which is ordinal, categorical, and coding data. Then you'll be able to learn data visualization, and you will have the insight into the roles played by a machine learning engineer. You'll be able to describe machine learning work with real-time data and learn tools and techniques for predictive modeling as well. And you will be able to discuss machine learning algorithms and implementation. You will be able to validate machine learning algorithms and explain time series and its related concepts. So let me assure you guys, with instructor-led interactive session, class recordings, lifetime access certification, industry projects, and 24/7 support, Python certification for data science is the best grab out there in the market right now. And now that we have come to the end of the session, guys, don't forget to subscribe to Edureka and press the bell icon to get the latest updates on Edureka and enroll to Python certification to data science. The link is given in the description box below. And for more details, you can visit us on edureka.co or call us, and the contact details are also given in the description box as well. So don't wait for the data science market to flourish, guys. Start today and become the masters of tomorrow. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!